Hello and welcome to my channel Stat Academy. In today's video, we should discuss about the topic mean deviation. We already discussed about the definition of dispersion and its measurement, and we also discussed about range in our previous video. So if you missed that video, then the link will be given to our description box. So the mean deviation is actually the mean of absolute deviations of the given values of the variable from some average. So to know it more precisely, let's just take a random variable x and suppose it takes n values x1, x2 up to the nth term xn, and let's just take c, any chosen average. Then the deviation is xi minus c of the values from any chosen average c. The greater the deviation, the more is the dispersion. Now to get a suitable measure, it is necessary to combine all these deviation. So we should take the arithmetic mean of this deviation. So we should divide this by 1n and sum all the deviation I from 1 to n. But we can see as c is an average, sum xi will be less than c and sum xi will be greater than c. So when we sum all these values, then we get a smaller value than the actual deviation. So to overcome this problem, we just take the magnitude of the values. So the formula for mean deviation about any chosen average c is denoted by md suffix c is equals to 1 by n summation I ranging from 1 to n mod of xi minus c. So we just take the magnitude of the deviation. Now if we take c is equals to x bar, then we have the formula of mean deviation about mean x bar, and this is equals to 1 by n summation I ranging from 1 to n mod of xi minus x bar. So this is the formula of mean deviation about mean. Again, if we have the variable values x1, x2, xn, and the corresponding frequencies as f1, f2 up to fn, then the formula of mean deviation about c for frequency type data is mdc is equal to 1 by n summation I ranging from 1 to n fi mod of xi minus c. So this is the formula or definition of mean deviation. Now we should see an example on this topic. Suppose we have to compute the mean deviation about median of a variable assuming the values 3, 5, 9 and 1. So we have to find first the median of this set of values. To find the median, we just have to rearrange the values in ascending or descending order, and we are arranging this in ascending order. So the values will be 1, 3, 5 and 9, and the median will be the arithmetic mean of 3 and 5. So the median ME is equals to 3 plus 5 divided by 2. That means 8 divided by 2, that means 4. So our median will be 4. Now The mean deviation about median is denoted by MD, ME is equals to 1 by n, that means total number of values, and here the total number of values is 4. 1 by 4 summation of the first value is 1 minus 4. We should take the mod value of this, plus mod of 3 minus 4 plus mod of 5 minus 4 plus mod of 9 minus 4. So this is equals to 1 divided by 4, 3 plus 1 plus 1 plus 4, 5. So the sum is 10 divided by 4, that means 5 divided by 2, or we have 2.5. So the mean deviation about median will be 2.5. Now move on to our next topic. We should see a property of mean deviation about mean. So this is the property only which is applicable only for mean deviation about mean, and it says that when we have to find the mean deviation about mean, we should use the formula 2 divided by n summation the xi's which are greater than x bar, xi minus x bar, or 2 by n summation those xi which are less than x bar minus xi. Now we should prove this property here. We know that summation I from 1 to n mod of xi minus x bar, we can write this as summation of xi greater than x bar, xi minus x bar, plus summation of xi less than x bar minus xi. Again we know that the sum of deviation of variable values from its mean is 0. Summation I from 1 to n xi minus x bar is equals to 0. We can prove this also. Summation of xi minus x bar is equals to summation of xi minus summation of x bar. Now from the formula of mean we know that summation of xi is equals to n into x bar, and as x bar is a constant, if we sum this value up to n we have n into x bar. So we have nx bar minus nx bar, that means equals to 0. So we can write summation of xi minus x bar in two form. Summation of xi, those are greater than x bar, xi minus x bar, plus summation of xi which are less than x bar, xi minus x bar, and if we sum these two terms then we have 0. And from here we have summation of xi greater than x bar, xi minus x bar is equals to minus of summation xi less than x bar, xi minus x bar, or we can write it as summation xi less than x bar minus xi. So we have that summation of xi greater than x bar, xi minus x bar is equals to summation of xi less than x bar minus xi. Now we should put this into our equation number 1, and we have summation of mod of xi minus x bar is equals to 2 into summation xi is greater than x bar, xi minus x bar, or 2 into summation those xi which are less than x bar, xi minus x bar. Now to find the formula of mean deviation about mean, we have to multiply this by 1 by n, then 1 by n summation mod of xi minus x bar equals to 2 by n summation xi minus x bar for those xi which are greater than x bar, and 2 by n summation xi less than x bar minus xi. So this is one of the most important property of mean deviation about mean, and depending on this we should take an example. So the example says that find the mean deviation about mean for the following frequency type data. We have height and frequency of some Students, so first we have to calculate the class boundaries and we have to reconstruct this table. Class boundaries, then the class mark, then the frequency. Now the class boundaries are 59.5 to 62.5, 62.5 to 65.5, 65.5 to 68.5, 68.5 to 71.5 and 71.5 to, this will be 72, 71.5 to 74.5. The class marks are 61, 64, 67, 70 and 73, and the corresponding frequencies are 5, 18, 42, 27, 8, and the total frequency is 100. Now we have to find the mean from this data set. The formula for mean x bar equals to summation of xi fi divided by summation of fi. So we have to find, here the class mark is our xi and the frequency is our fi. So we have to find first the value xi fi from this table. So 5 into 61 is equals to 305. 64 into 18 is equals to 1152. Then 67 into 42 is equals to 2814. Then 70 into 27 will be 1890 and 73 into 8 will be 584 and the sum is 6745. So our mean will be x bar is equals to summation of xi fi, that means 6745 divided by summation of fi, that means 100, and the mean is 67.45. Now from this we can see that those values which are greater than the mean are 70 and 73. So using the previous property, we just take these two values to find the mean deviation about mean. So our xi which we take will be 70 and 73 because these are greater than 67.45. Now we should find xi minus x bar. So the xi minus x bar will be 70 minus 67.45, that means 2.55, and 73 minus 67.45, that means 5.55. Again the frequency fi is 27 and 8. So fi into xi minus x bar will be 68.45 and 44.4, and the sum of this fi into xi minus x bar is 113.25. So we know the formula for mean deviation about mean is 1 by n summation fi into xi minus x bar for those xi which are greater than x bar. So this is equals to 1 by n, that means 1 divided by 100 into the sum of fi into xi minus x bar, that means 113.25. Okay, the formula is 2 by n. md x bar for those which are greater than x bar is 2 by n summation fi into xi minus x bar. So this will be 2 by 100 into 113.25, and this will give the answer 226.5 divided by 100, that means 2.265. So the mean deviation about mean for this frequency type data will be 2.265. So that's all for today's video. If you like my explanation, then please subscribe my channel and hit the bell icon. Thank you for watching.